Hello, in this video I'm going to convert the network to a digital asset and add parameters to allow the user to customize the pile.
So let's move this null up here. So these nulls are our inputs here. We've got an input for the geometry we want to pile up and any collision geometry that we want. And then we have our output down here, which is the end of our tool. Now I want to select these two input nulls and then select everything all the way between them and our output. I'm going to leave the output deselected and then come up to this cardboard box icon up here and click that. That will convert our selection into a subnet. Let's just hit L to lay out all of our nodes. And then we can right click on the subnet and come down to digital asset, create new. We can name this PE underscore pile. And I'm going to uncheck author and set the menu entry to be Pegasus. So this will be the menu that will appear under when we right click in here. So it's going to appear under Pegasus. And we want to have our label for our tool PE pile as well. We've been using this prefix PE on all of our Pegasus tools, so they kind of are all grouped together when we search for them.
By default, Houdini will save the digital asset into the user preference directory, which is the Houdini folder in your user documents folder. If you watched my video series on setting up a package file and going through our folder structure, then you'll see I created a custom variable which I can use to save all of my digital assets for Project Pegasus into our project folder structure. I'm going to use that variable here now. You don't have to do this. You can save the digital asset to the user preference directory and import it into Unreal from there. The workflow will work the same. I just want to demonstrate the workflow that we used on Project Pegasus. So I'm going to change this library path to custom and then type in that custom variable I created in the package file, which is $Pegasus demo. As soon as we type that in, you can see this update down here to that package. And then we want /OTLS for the OTLs folder, and then we can hit create. And then we have the type properties window opens. First thing I want to do is add a custom icon to our tool. So here I have a custom icon that I've been using for the Pegasus digital assets. And hit apply. So now we have our subnet converted to a digital asset with our own custom logo. You can easily identify this as a Pegasus tool. So let's go inside and start adding some parameters. We have our two inputs up here. Let's just organize these a bit more. We have input 1 for our geometry that's coming into our tool, and then this collision object under input 2. Let's just bring this input collision down here. Okay, so the first thing I want to add is this switch node, so we can swap between our two different methods of assigning a piece attribute. So let's select the switch node and select this select input label here and drag and drop it into the parameters here. And I want to change this from an integer to an ordered menu. Let's rename this to split by. And if we come over to the menus tab, we can assign a menu. So we have two inputs, input 0 and input 1. So for the first menu item, we want 0 and the label to be connectivity for our connectivity node. And for the second input, we want to use a piece attribute. So second input is an index of 1. And here we're going to set the menu item to be piece attribute. And then on the attribute swap, I want to take this source and add this to the parameters as well. So this way, the user will be able to change the name attribute that they're using. So let's name this attribute name, and hit apply. We take a look at our tool now. You can see we've got an ordered menu, connectivity, piece or piece attribute, and an option to specify what piece attribute we want to use. Now let's come up to split by and just check horizontal join to next parameter, and then hit apply. And there we go, these are side by side now, so these make these a bit clear that these are being used together. And actually, if we select connectivity, we're not using this parameter here. So let's come to the attribute name parameter, and in disable when, let's open curly brackets and type split by not equals, so exclamation mark equals 1, close curly brackets, and hit apply. Now you can see this has now become disabled. If I select piece attribute, it becomes enabled. So now it's clear when we need to use this attribute and when it's not being used. I want connectivity to be the default value. So with it set, come up to split by and right click and select copy defaults from node and hit apply. And now we can see that is the default value. And if we just click on this source, we can see this here. We've got the link to the channel on our digital asset. I'm going to copy it and come down to the bottom here to our swap attribute down here as well. And I want to update this destination to also be linked to our digital asset as well. And I just need to encase that expression in backticks. Now if we middle click on destination, so now we can see we're getting the name of this attribute from our digital asset. Say we were to change these piece attributes from name to call them, say, piece. We can then update that piece attribute to be called piece. And there you go. Now you can see them updating to use that new attribute. Naturally, now that I think about it, we come inside our pile attribute. Currently, we're using a piece attribute. There's the user is specified, such as name. At the end here, we're swapping from this internal attribute, which we've been using, back to the user-defined attribute, which we've now just changed to piece. But you might the user is actually using connectivity rather than piece. So we actually want to have down here a switch if. So let's add a switch if. And let's connect this to the second input. And on the first input, I'm simply going to add an attribute delete. And rather than swapping this piece attribute, this pile name, I'm going to delete it instead. The attribute's on primitives, so let's select there, pile name, and delete the attribute. And in the switch if, we're going to write an expression in here which will change whether or not this switch is enabled or disabled. So let's come up to this switch here, copy parameter, and in the switch if, paste that into here. So paste relative reference. And we want to say is equal to 1 and hit return. So now this switch if will be enabled if this switch is set to an input of 1. And now we can see that as swapped. So if we're using a connectivity node, we will simply delete our piece attribute so it isn't visible once the geometry leaves the output, or we will swap it back to the user-defined piece attribute if they have chosen that option. And if on our output we can see, if we look at our geometry spreadsheet, if we're using a piece attribute, we still have our piece attribute maintained as it was when it went into our digital asset. And if we swap to connectivity, let's bypass these nodes. So now we're not using a piece attribute, we're simply using connectivity, and we don't have that internal attribute coming out of our digital asset. So let's continue to add a few more parameters. Let's add a transform node after this for each, so that the user can rotate the geometry or scale it up and down if they want to. And we're going to add a folder here. Let's make it a simple folder, and let's name this input geometry. And let's add rotate and uniform scale. Let's add another folder. This one I'm going to call pile scatter. And for this one, I'm going to add our grid. Now I want the user to be able to set the size of this grid. Let's just make this visible, because changing this grid will make the pile bigger or smaller. There we go. So now we're getting a bigger pile as we make this object bigger, and we get more objects kind of copied to it. Just increase the density scale a bit, so say 4. The bigger the grid, the more objects we get to scatter and to add to our pile. And I don't want the user to just have these parameters change. I like them to have access to this gizmo. If we right click on the gizmo for our grid and click export handle to digital asset, move this up. And now we can see we've got these parameters appearing in our type properties. Let's add this to the pile scatter folder and hit apply. And take a look at our tool. And with our tool selected, if we click show handles, we now see we've got that grid handle available from outside of our pile tool. So we need to reset simulation. We can reset simulation by coming down to this little brain icon and right clicking and clicking reset all simulations. There we go, that's reset the simulation. And so now you can see changing this grid is going to increase and change the shape and size of our pile. Let's just set these values back to default. We need to change this folder type to simple and then set some default values. So I want the default size to be 2 by 2 and the center to default to 0. Let's right click on center and click copy defaults from node. And with size, I'm just going to rename this from pile scatter to pile grid, because I'm going to add another folder called pile scatter here, and that's going to be the attributes for the scatter and align node. Take a look at our scatter and align, and I want to add the density scale as well as the max random cone angle as well. Let's also add this global seed. Let's have the range set to a maximum of 100. And we also need that folder to be a simple folder. Okay, so we've got a few good parameters on the go now. What else can we add? Well, let's add some options to control our bullet solver simulation. Let's add another folder. This we'll call pile simulation. So, first of all, let's add this reset simulation button. And also, I'm going to add this time shift frame as well. So that way we can choose a later frame or maybe an earlier one. Let's change this type from float to integer. And let's set the max range to say 300. Also change that to a simple folder. And I also want to have the option to view this collision object whilst I have my tool visible. And I also want the option to enable or disable the container as well. So let's add a couple more switches. So after this merge node, let's add a switch here. And this is going to be called switch use container. Let's add a null. This is going to be called no container. And we want the no container to be the first input and the container to be the second input. So let's add this select input to our pile simulation as well. I'm going to call this use container. And we want this to be a toggle. And to make a piece of a guide geometry that we can view from outside of our digital asset, let's add another switch, pull off this merge and add a null and call this guide geo. And come over to node tab on our type properties window and just drag and drop that null into the field for guide geometry. And if we hit apply, take a look at our digital asset, we now have this blue wireframe of our container and our collision geometry. Let's just make this container a little smaller. Let's say to a value of 2.5 instead of 5. There we go. That's a bit more clear and a bit more manageable to look at. And I want the option to be able to turn off this guide geometry. I don't want it always to be visible. So before this null, let's add another switch. This is going to be switch show guide geometry. Again, we're going to add a null to this. And this is going to be called no guide. Again, we want this to be the first input on our switch. And then coming back over to parameters, add this switch as well to our pile simulation and call this show guide. We also want this to be a toggle as well. And apply. So now we have an option for whether or not we want to use a container. If I disable that, we're actually no longer using a container, but actually it's switched off our collision geometry as well that we're using on the input, which we don't want. So let's reposition this switch. So rather than this coming from the merge, we want this to come from our poly extrude. And then let's replace this with our switch. So move this around. And then we also want to connect this merge back to our bullet solver. So now our poly extrude is coming into this switch, and the user can disable this if they wish, and then that goes into the merge and into our bullet solver. So now I show the guide geometry, still got the collision geometry. If I check use container, now we're back to using container. Now that's working correctly. And finally down here we have our switch for whether or not we're going to leave our geometry packed or unpacked. So let's add that. Let's add that to a folder called output geometry. And you want that to be a simple folder. And now let's add that switch. Oops, put it in the folder. This is going to be called unpack geometry. And I'm going to change the type from integer to toggle. And hit apply. Now let's right click on our null and select save node type. So that saves all of the changes we've just made to the digital asset. And now we can bring this into Unreal and test it to see how it works.